Hello friends, I am Professor Swanand Dongre, and in this video we are going to study the concept of wattage of resistor, that is also known as the power handling capacity of resistor. Friends, have you ever seen the 1 kilo ohm resistor of small size, 1 kilo ohm resistor of medium size, 1 kilo ohm resistor of big size and that of very big size? So all these resistors, they are having same resistance value 1 kilo ohm, but why there is difference in the size? So if you consider, say, you can have this 1 kilo ohm resistor of small size, then you can have 1 kilo ohm resistor of the medium size, you can have the 1 kilo ohm resistor of the big size, right? And you can have the 1 kilo ohm resistor of very big size. So there is increase in the size of resistor, though their value is same, say 1 kilo ohm. So what is the significance of size? So this size is related to the power handling capacity or wattage of resistor. So if you consider this first resistor, if it is of say 0.25 watt, then second resistor say 0.5 watt, third resistor say 1 watt, fourth resistor say 2 watt. So with increase in the size of resistor, its power handling capacity increases. But what is power handling capacity or what is wattage? So you can find this power handling capacity by simple formula: power is equal to V square by R, or it is equal to I square into R. And as it resistor, there is no phase shift between the voltage and current, so that is why we can find power using this simple formula. And one more thing, the resistor behaves same for DC quantity as well as AC quantity. So its behavior is same for DC current or voltage or AC current or voltage. So there is no change in its functioning. So it is not dependent on the frequency also. The resistance value is same for lower frequency as well as higher frequency. So in this formula, P is power, which can be handled by that resistor. V is nothing but the voltage across resistor. I is nothing but the current flowing through that resistor. So using this formula, we can find the power handling capacity. In our lab, we are having the different resistors. We can find the different resistors. The smallest resistor which we have is having the wattage 1 by 8 watt. It is 1 by 8 watt, that is 0.125 watt. Then after that we are having the resistor of 1 by 4 watt, that is quarter watt, 0.25 watt. Then half watt, that is 0.5 watt. Then 1 watt, 2 watt, then 5 watt, 10 watt. So this is nothing but the wattage of resistor, and with increase in the wattage or power handling capacity of the resistor, its size also increases. Now let us take one practical example. In a circuit, if you want to connect a resistor, so along with its resistance value, you have to also consider its wattage. For an example, you are having a circuit. Say this is a circuit. So in this circuit, there are different components, there are different connections, and there are 2 points in this circuit. There are 2 points in this circuit. And I have to connect there a 1 kilo ohm resistor in between these 2 points. But the voltage which is appearing here in between these 2 points is say 10 volt. So it is 10 volt, and I have to connect the 1 kilo ohm resistor in between these 2 points. So along with this resistance value, I have to calculate the power handling capacity. So I'll calculate the power handling capacity using this formula, because I know the voltage which will appear between these 2 points. It is nothing but V square by R. So what is the voltage? It is 10 volt. So 10 square divided by 1 kilo ohm. So what will be the power? Power will be equal to 100 divided by 1k, that is 0.1 watt. 0.1 watt. So I can use a resistor whose power handling capacity is greater than 0.1 watt. Generally we take the resistor whose power handling capacity is twice of the calculated value. So here it is 0.1 watt, its twice is 0.2 watt. So that is why for this application I will select a resistor of quarter watt. 1 kilo ohm resistor of quarter watt. So this is the significance, right? Now if you don't care about this power handling capacity, what will happen? Let us consider in the same circuit, if you want to connect the 1 kilo ohm resistor and the voltage which is appearing here, it is say instead of 10 watts, instead of 10 volt, it is say 100 volt. right, in between these 2 points. Now consider case 2, right? Here if you use the formula, power is equal to V square by R, voltage is 100 square divided by 1 kilo ohm, so that is why it is 100 multiplied by 100 divided by 1k, so it is 10 watt. Now if voltage is increased, I can't use there the previous resistor of the quarter watt. Here the calculator power dissipation is 10 watt, so I have to select a resistor whose power handling capacity is greater than 10 watt. So this is the significance of resistor and its wattage and power handling capacity. That's it. Thank you.